In the mathematical field of numerical analysis, a Newton polynomial is the interpolation polynomial for a given set of data points in the Newton form. It is sometimes called Newton's divided differences interpolation polynomial because the coefficients of the polynomials are calculated using divided differences. Thus, it is a way of finding an interpolating polynomial. Interpolation polynomial is defined as a polynomial that fits a particular set of data points. In other words, given some data points obtained from sampling, the aim is to find a polynomial that gives exactly through these points. It is said that the interpolating polynomial is unique, so whether you apply the Lagrange method or the Newton's divided difference formula, you'll find the same interpolation polynomial. The Newton's divided difference uses the following formulas. Okay, these are the following equations used by Newton's divided differences. Divided difference coefficients have number 1, first order divided difference, wherein divided difference between x of 0 and an x of 1 is equal to f of x of 1 minus f of x of 0 divided by x of 1 minus x of 0. The second order divided difference have this formula. The divided difference between x of 0, x of 1, x of 2 is equal to f of x of 1 and then x of 2 minus f of x of 0 and then x of 1 divided by x of 2 minus x of 0. The third order divided difference has this formula. F of x of 1, x of 2, and then x of 3 minus f of x of 0, x of 1, x of 2 divided by x of 3 minus x of 0. And then the fourth divided difference of order n, or the Newton's divided difference, would be equal to f of x of 1 up to x of n minus f of x of 1, x of 0 up to x of n minus 1 divided by x of n minus x of 0. Interpolating polynomials. These are the different equations for us to be able to interpolate polynomials. To get the interpolating polynomials, we have this equation multiplied by x minus x of 0. And then this equation will be multiplied by x minus x of 0 times x minus x of 1 and so on. And adding the result will yield Newton's divided difference formula, which is suitable for computer implementation. And this is the divided or the Newton's divided difference formula, wherein f of x is equal to f of x of 0 plus x minus x of 0 times f of x of 0, x of 1, plus x minus x of 0 times x minus x of 1 multiplied by f of x sub 0, x of 1, x of 2 plus up to x minus x of 0 up to x minus x of n minus 1 times f of x of 0, x of 1 up to x of n plus r. And to sum up this equation, we have f of x is equal to p sub n of x plus r, wherein r is the remainder, which have this equation. R is equal to x minus x of 0 times x minus x of 1 up to f of x, x of 0, x of 1 up to x of n. This is our divided difference table. The divided difference are conveniently evaluated within the table as shown here. As you can see, I serves as our reference points. X of I are the first values of the equation, or what we call the domain. f of x of I serves as our second values, or what we call the range of the function. This is the first order divided difference, the second order divided difference, the third order divided differences, and the fourth order divided differences. Notice that the table is arranged so that the function values required at each stage are adjacent. Let us have our example using the Newton's divided difference formula. Estimate f of 2 and f of 4 using the Newton's divided difference formula and find the interpolating polynomials given the following data. So these are the data that we will be using for us to be able to get the solution. The first step for us to be able to solve for these values is make a divided difference table by applying the formulas in finding the divided differences coefficients. For us to get the divided difference between 0 and 1, let's have negative 6 minus 1 divided by 1 minus 0 is equal to the first divided difference, which is negative 7. To get the second order divided difference between 0 and 3, we'll have 5 minus negative 7 divided by 3 minus 0, which will result to positive 4. For us to get the third order divided difference of between 0 and 6, we'll have 10 minus 4 divided by 6 minus 0, which is equal to 1. And for us to get the fourth order divided difference between 0 and 10, let's have 1 minus 1 divided by 10 minus 0, which is equal to 0. As we have seen in the previous table, the third differences are constant. So we shall use the table to interpolate by means of Newton's divided difference formula and determine the corresponding interpolating cubic. For f of 2, use x of 0 is equal to 0, x of 1 is equal to 1, x of 2 is equal to 3, and then x of 3 is equal to 6. So this is our formula, and we will just substitute the given values to the formula for us to be able to get this solution. And then the result will become P of 3 of x will become x cubed minus 8x plus 1. And then P of 3 of x is equal to P of 3 of 2, since f of 2 means that x is equal to 2. Then P of 3 of 2 is equal to 2 raised to 3 minus 8 times 2 plus 1, which is equal to 8 minus 16 plus 1, which will result to negative 7. To solve for f of 4, use x of 0 is equal to 1, x of 1 is equal to 3, x of 2 is equal to 6, and then x of 3 is equal to 10. And then again, we will make use of this formula and then substitute the given values for us to be able to arrive to the solution. And then, these are the solution using the values given. We have the following values, which will result to P of 3 of x, or P sub 3 of x is equal to x cubed minus 8x plus 1. As expected, the two interpolating polynomials are the same cubic x cubed minus 8x plus 1. And then P sub 3 of x is equal to P sub 3 of 4. Since f of 4 means that x is equal to 4, then P sub 3 of 2 is equal to 4 cubed minus 8 times 4 plus 1, which would equal to 64 minus 32 plus 1, and then would result to 33.